This first segment that we're going to do is passing the knot utilizing a CMC CSR kit. So that is typically their confined space component. It's a pre-built 4-to-1 system or 5-to-1 system, depending on how you integrate it. It has an integrated progress capture device with friction control so that you can adjust both the deployment of that system as well as ensure that it safely sets when loaded. The system is very quick and easy to deploy because it's all pre-built, and this application obviously is in a hauling type of format. So we've got an MPD rigged in here. Our haul team is in the system and we're hauling up our load. As the knot progresses towards my hub or towards my MPD, as the operational commander, I would call stop when that knot is in close proximity to the MPD, but not so close that I can't progress the system. Once that knot is in close proximity to the MPD, I would rig in my secondary system, which in this example is a CSR kit. I'd attach it to this primary system utilizing Prusiks, and I would then haul that load on this piggybacked CSR system. As I haul that load, that's going to manipulate the load up. It's also going to generate slack behind that Prusik or progress capture component, allowing us to take that knot, unrig the rope from the MPD, and place that knot on the back side of the MPD. At that point then, we can transfer our hauling operations back to the primary system, start hauling on the system, which will then in turn generate slack on the CSR kit and allow us to break that system down. Haul team ready?
Haul team ready.
Haul team, haul fast.
Haul fast. On rope. On rope. Off rope.
Haul team, stop.
Up.
So you can see we've stopped our hauling applications with the midline knot in close proximity to the MPD. So we're now ready to integrate or put on our piggyback system utilizing the 4 or 5-to-1 CSR kit. You can see that this system has a toggle lever on the side with a clear indication of an arrow and the words release. The arrow indicates that in the down position, this system can extend out. As soon as that toggle lever extends up or into the lock position, the system can no longer deploy out. So this is up is maximal frictional control, down is minimal frictional control. You want to look at the pull lane and the environment accommodating your haul lane, and you want to make sure that you orient this so that you have enough space to effectively operate it. So you may rig this in as a 5-to-1 or you may rig it in as a 4-to-1 depending on what your haul lane accommodates. Okay, so we've got our piggyback system rigged in. We've got our progress capture component or our Prusik rigged on for our Z-drag or our capturing element on the tension line. And what you need to understand is the overall objective. We're trying to pull just long enough to progress the system so that this knot can effectively get rigged in on the back side of the MPD. So it's going to be a very minimal haul. Haul team ready?
Haul team ready.
Haul team, haul slow. Haul team, stop.
Stop.
You can see that the system self-sets with the tension. Toggle lever has effectively captured all the progress that we've made, and we now have enough slack in this system to effectively take our MPD, unrig it, and place our knot on the back side of where it was previously rigged. Haul team, transition to primary haul line. Haul team ready?
Haul team ready.
Tension the system.
Tension the system.
Haul team, haul slow.
Haul slow. On rope.
Haul team, stop.
Stop.
Once we've built slack into the CSR system, we're now in a position to take off our progress capture device or our Prusik and set our CSR system off to the side with our primary haul system back as the primary hauling component.